Hey everybody, so in this video we're going to see how we can transform our sine and cosine graphs, and I'm gonna share some of the shortcuts that you can use instead of having to graph your sine and cosine graph like multiple times. So last week you saw how to graph parent sine and cosine and tangent function. So those are just the parent graphs. And after that, you saw some of the features of sine and cosine graph. And those are the midlines and the amplitude and period. And also you saw how you can transform your function vertically and horizontally when they get stretched. And in those videos, you saw them how you do it each step of your graph. So you kind of had to graph it every time. And you also saw how you can graph your function that is being stretched vertically, and also when you reflect it horizontally. So when you flip it horizontally. Okay. So just a reminder here, when you have your graph equation, your A is the value in front of your sine or cosine, and the absolute value of that will be the amplitude of your sine or cosine function. Okay, so how tall it is, it kind of determines how it got vertically stretched. Then the B value determines your new period. So you divide that B value by, or you divide 2 pi by that B value and you get your new period. And just kind of take notice how your B value is factored out, so it should be outside of the parentheses, but still within your sine function or cosine functions. And your C value is the horizontal shift, or we can also call it a phase shift. Okay, we use it interchangeably. And also notice how C value does not include your negative sign. And lastly, your D value is how many units your graph is going to get shifted up and down, which also is your new midline. Okay, so just keeping that in mind, and I'm going to actually make a table for our sine function. Okay, so let's graph our regular sine function. Make a table for that. So we got y equals sine x, and when your x is at 0 from your unit circle, okay, your sine value was 0. And because our sine function, your period is what? It's going to be 2 pi over b, right? But what's our b value? We don't have anything. In fact, 1 is hidden there. So our period for our parent function is just 2 pi over 1, which is just 2 pi. So we are going to get our subinterval. You always get your subinterval by dividing your period by 4. So you need at least 4 increments so that you can graph your sine function. Okay, so I'm going to tell you what that means. So when you divide 2 pi by 4, it's going to be pi over 2. This gets simplified, right? So the next one that I'm going to write down is pi over 2. And what's my sine of pi over 2 value? That will be 1. And after that, we're going to add another pi over 2 because that's our subinterval. So you add pi over 2, and then you get pi over 2 plus pi over 2. That will be 2 pi over 2, which is going to be simplified to a pi. And what's my sine value at pi? 0. Okay. And then one more, if you add pi over 2 to get my next increment or next subinterval, that will be 3 pi over 2. And at 3 pi over 2, your sine value is at -1. And one more, I'm running out of space, but here I'm going to do 3 pi over 2 plus pi over 2, that will be 2 pi. And at 2 pi, we're going to come back to 0. Okay? So, I think one thing you can notice is our sine function starts from our origin. Okay? Or also, our midline for sine function is what? When your y value is equal to 0. Right? So we're not really adding anything, which is 0, and our midline is 0, which I can say our sine function always starts from our midline. Okay? And your 1, that's the maximum value. It goes as high as 1, okay? It doesn't go any further. And after that, we come back to midline. And then after that, what's my minimum value of sine function? -1. Then it goes back to our midline. So our sine function always follows this pattern where we start from our midline and it hits maximum point, and then it comes back to midline, and then it goes down to -1, which is our minimum, and it goes back to our midline. So it oscillates back and forth between my minimum and maximum. Okay? So, just quick. This is y, this is x, and I can always divide my interval by pi over 2, just like we got it here. And this is pi, 3 pi over 2, this is 2 pi, -pi over 2. And what happens is, it starts at 0, and it goes as high as, I'm going to just go up to here, 1 and -1. Maximum, midline, minimum, midline, okay? And then, you can still follow the pattern, maximum, midline, minimum, midline. So, you connect all the points. And it follows this pattern. It keeps oscillating between these values. Okay? So just keeping that in mind. Okay. But what about our cosine function? Our cosine function is really similar. Okay, just like our sine function, we can get our period, which is just 2 pi. And what's my midline? My midline is also at y equals 0. Okay, and because my period is 2 pi, our subinterval will be still 2 pi over 4 or pi over 2. So I start at 0, and we have at 0, what's my cosine value? That will be 1. Then after that, we get pi over 2. Cosine value at pi over 2 will be 0. 3 pi over 2, that will be -1. And lastly, 2 pi, what's my cosine value at 2 pi? We come back to 1. Okay? So, when we graph that, we get pi over 2, pi, 3 pi over 2, 2 pi, and you can keep going, which will be 5 pi over 2, this is -pi over 2, so that's how you determine your increment or your subinterval. Okay? And at 0, my y value was 1. And then at pi over 2, my y value was 0.